Howdy, y'all. How are you doing? Hi, Bill. Bill is joining me this morning. How you doing, Bill?
Not too bad. I'm working on the galactic coordinates you gave me.
This is becoming a thing. It's like I have to do this now, which is fine. Yeah, I'm back on Facebook now. Now that the nudity is over, apparently. Big fiasco with nudity. Oh, your husband has gotten himself into very entertaining hot water when he returns.
Pepper?
Yeah.
Oh.
Because he put down this gauntlet for 8 pages in 2 hours.
Oh, yeah, I heard.
So yesterday, I tried it yesterday morning, and I got 2 pages in, which wasn't bad. But last night, would you believe it, Ken actually made it all the way to the end. 2 hours. So now Pepper's time to beat is Ken's, not mine.
He did want to join, but we had went to Estes Park for his birthday. And like he got sunburned and he was just totally exhausted by the end of the day. So
it's totally cool. I'm not worried. I'm glad to have you here. And you're working on the code, which
yeah, I figured why not?
Okay. I'm okay with this, totally. You're not going to hurt me at all.
2 of the HIPs, by the way, you gave me are not in the database, at least not the database that this one outputs.
Oh, yeah, that could be entirely plausible. I went to Wikipedia's webpage on galactic coordinates, and it did the galactic north is really close to this star, and galactic south is really close to this star. And so I just gave you the numbers, assuming they'd be in the database.
Oh, okay.
But the database is based off of a spacecraft that's trying to tell their distance. And so it just may be that the spacecraft hasn't yet worked on that star.
Got
it. Which that would make some sense, but you know. So I am working on redoing the MPV. This is my newer version of it. Actually looked pretty cool. The only problem is that when I imported the legs, they imported in at about 110%. So not really much bigger, but a little bigger. And the first time I saw them, I'm like, I don't know, man, that doesn't look right. But now that I had a night to sleep on them, I've been kind of like, I don't know, didn't look bad actually. It's fine. And it fits, it still mechanically fits, which I think is important because I know that at least Brent wants to very badly print these things and make this. So if the mesh is crossing over itself, it won't print very well and it won't assemble well. But so far, it's kind of coming along pretty nicely. I think, oh, I didn't tell you, for the challenge that I did, I actually was inspired by you. So I went into Chat GPT and said, write me a script for an 8-page comic about a girl and a space cat. And we spent the entire night watching it just write these like cute little adorable fluffy adventures of these 2 characters. And I'm like, I totally want to write this now. I mean, it's actually like, you know, they were so like innocent, and that's why it was even funnier that we got nailed for nudity. because that's the last thing you do on a it was like a children's book-esque.
Mm-hmm.
It was so cute.
Yeah. I don't know if I can blame the AI system for being horrible, or just that we need to have a system to detect such things. Maybe that's the real problem.
Yeah, I think that's exactly right. I think we need to come up with a way to protect our work. I mean,
Mm-hmm.
We can't have the AIs taking our jobs away. That's not cool.
Mm-hmm. And then shutting you down when you are doing work. Here's Pepper.
Yeah.
Messages from Pepper.
Hey, Pepper. How you feeling?
So did I read that correctly? Did Can do all 8 pages last night on the stream?
He totally did.
Uh-huh.
So we were like, Pepper's coming back to a big challenge on this one, because I didn't do it. I made all of 2 pages. But Kayan certainly did.
Did you already have like a script and everything ready to go?
Yeah, I mean, we both did, because I went on ahead, and that was what I was just telling Bill. Inspired by his coding via ChatGPT, I too decided to use ChatGPT for the script.
Uh-huh.
So we had it generate this actually rather adorable story about Space Cat and her owner Leela, which is oddly the name that ChatGPT came up with.
Oh, okay.
So it worked really well.
Cool. All right. Well, I have to go to an appointment. That's why Bill is on here. Thank you for the birthday wish. Hello, Brent. Well, my appointment is at 9:30, so when I get back, you'll probably still be streaming.
Oh, that's plausible. It is entirely plausible.
And I thought it was Watercolor Wednesday.
It is Watercolor Wednesday. I don't know where my watercolors were. But since Pepper is here, I was like, so I was going to clean up my office today so I could find my watercolors, right? Because they're somewhere in here. And I don't know where. But then it's like, but Bill's here, and I probably should talk to Bill for a minute. So.
Well, I told Bill that he should actually just take one of my things for watercolors and do watercolors with you, but he said he refused.
This is my watercolor right here. Look at all the colors. Isn't this pretty?
It is very colorful. you are definitely off your work for the day, which is this is your version of taking a break. So I'm okay with that. Which is usually why we do Watercolor Wednesday, is so that we will all be forced to break.
So I had taken a week off for our birthdays. And I was like, if we ever win the lotto and I decide I don't want to work anymore, we're gonna have to figure this out, because just doing nothing, I was like I'm gonna go insane. I need a problem to solve. I need to do something. So it's one of the reasons I'm working on it, because I need something. Give me something.
Which it works for me. You are solving one of my, literally 2 years I've been struggling with this. And I've been trying to do the code myself, and all I end up with is stars not in the right place. So when the database put the stars out, I know that from, let's say, for example, I'd be, hey, Emily, I'd be in one star, like say Sol, and then I would know that the Bellatrix was supposed to be, let's say 250 light years from Sol in this direction, and I'd spit out all the data, and Bellatrix is over here. And I'm like, and they aren't consistent. Like Bellatrix is here and Moment is here, and then I'll redo it, and then Bellatrix is here and Moment is here, and I'm like, whoa, wait, what? None of them are consistent, which means that I'm just doing lousy math, which is totally a thing. What's happening, Emily? Oh, I love your avatar.
Well, I'm learning a lot about our perception of the universe, because when I was starting to get into like, okay, how am I going to do this? And I was like, okay, well, we can view the stars from the equatorial plane, which is the equator of Earth, our personal perspective of the universe. Then there's the orbital plane of Earth around. Let me back up. There's the equatorial plane, but the Earth precesses, so it's never the same. And then we're also going around the sun, so that changes things. Then there's the orbital plane, but even that precesses a little bit, so that's never exactly perfect. So it's like, okay, well then here's the question: what are the values in the database? Are the values in the database the equatorial plane or the orbital plane? Because if I adjust it thinking it's the orbital plane, but it's the equatorial plane, everything's off.
Right. Emily, we're doing great today. Both of us apparently are in computer mode, but normally I draw a comic. But I draw a comic with 3D models. So this is my 3D model day. And I'm working on one of the 3D models that I use in here. And Bill is our buddy who does programming. So he's been working on my star chart problem, which is still a problem. So that's why they do the J2000. You'll see that a lot too, Bill. The J2000 is a frozen moment in time of which to lock the planes together.
Okay.
Good morning, Cat. And so that's exactly what they're doing, is they're locking the planes so that that's the moment that everything is aligned to. So the day would be, I think it's January 1st, 2000. And it's locked to that. And so all of your numbers get locked into that position. But I also think that, so it would be called equatorial, celestial, and then galactic. Celestial is then what we call the orbital plane. That one's off by 60.2 degrees. But as we discovered, I think you're right too. I think that those numbers then are off by another 0.4 or 0.8 degrees. Because when I did the visual version of it, and I visually aligned everything, the numbers I got were not 60.2, but like 62.4 or something like that. So it was like, even then I'm sitting there going, that must be what's going on, is they caught the equatorial plane when we were precessing.
Right.
And when Bill's talking about precession, what he's talking about is the tilt of the Earth for spring and summer and fall and winter. We precess, which means from the point of view of the solar system, we're rocking back and forth. The truth is we're not. We're just tilted on one side, and we move around the sun still tilted on one side. But that still makes it precess across the orbital plane from perspective to perspective. So because the solar system's moving too. Everything's moving.
Which made sense, because I was like stuck on the 60.2, and I was like, why can't I get a more precise measurement on this? Like at least, 4 decimal points worth of precision.
Right.
And the reason is because you can't have that precision because we're moving.
Right. So we lock everything down by a date in 2000, and that's that J2000. Prior to that, it was what they called J1950, and it was the same thing. They locked everything down at 1950 on one day at one hour, and then locked everything in that moment, and all star positions were considered from that moment. So that should be all J2000 data. The problem, of course, is that Gaia is getting modern data right now. Like, Gaia is a probe that we launched that's in heliocentric orbit. So it's orbiting the sun, it's not orbiting the Earth. And so what it does is it looks at a star and then waits until it's on the other side of the sun, and then takes another picture of those stars. Then it can see the stars moving in parallax. And that allows it then to do the mathematics to see how far it is. Because the closer stars are going to move more dramatically than the farther away stars, which won't move as much. So whatever its parallax is, then it knows what its distance is. And that's why you'll see the parallax number in there. However, galactic coordinates are generally described with the letter lowercase l and the lowercase b. So the lowercase l is, I think that stands for longitude. I'm not sure. But that should be, you can see those online if you start looking for the lowercase l and the lowercase b. That's a galactic coordinate based to the galaxy. Because of course you'll use RA and DEC to indicate right ascension and declination, which would be reading from the Earth.
I found a cool Python library that's supposed to do this. That's what I'm using now. It's called AstroPy.
Okay, cool.
This is AstroPy, and it basically has like a coordinate system, and then you can basically convert. Error. Well, there's convert to option. I'm doing it in the code.
I just love the fact.
Okay, I'll transform to, and then you say transform to galactic.
Right.
And that was working. I don't know if I got the types right. Like I'm saying, the representation type I'm giving it is Cartesian. The unit is PC. I haven't defined what PC is yet.
Right.
And the frame is ICRS. So, copy pasting here. But I need something to verify. I need something like that I can go, okay, that's correct. That's perfect.
Okay. I'll spin up Celestia and we can do some spot checking. Because 60 degrees is enough of a wild number that we should be able to. Did I fire off 2 versions of it? I did. I just need 1 version. Okay. So we're on the ecliptic. So this is ecliptic specific. Right? So there's the sun. But my grid, I don't know if you can see my grid, but the grid here is set to galactic. If I were to change my grid, I can change my grid from galactic to equatorial. Right? Don't close. And if I set it to equatorial, then down is down via the Earth, and up is up via the Earth. So now we can just pick something. Let's pick something close from here. So we'll select an object. Sirius is a star that's 8.1 light years away. So we'll center to it. So there's Sirius. So Sirius reads galactically at minus, say, I don't know, it should be about 18 degrees, 19 degrees, give or take. And at about 7 hours, 7.5 hours.
You have the XYZ
minutes or so, or 6 hours 30 minutes is where, or I guess it's 6 hours 45 minutes.
You know what the XYZ of it is? Coordinates?
No, but I mean, I could probably find it in a second here. But the reason I'm doing this is that means that it's from Earth. It's going to be apparently, and I'm just trying to do the thing in my head here, because from Earth it should be up and back. So it's going to be from Earth specific. It'll be Z plus. That's actually the thing I'm looking for. Is if it's Z plus, then it switches to Z minus, then we'll know that that's at least one check. We can do a couple of other checks here in a second, but That's the one that. Oh, hey, look, it's Bellatrix. There's Bellatrix right there. Just saying. It's easy to see Orion, so I like the fact that my comic takes place around Bellatrix, because then it's easy to see the star. So let's switch then to our. I wonder if there's something I can do online that would help me find these things.
That's a good idea.
Hang on. Okay, here's something. Elite Dangerous has star maps in an XYZ coordinate system. So, from Earth, the galactic coordinates are 252.4 or 0.45 distance with an L of 197.24 and a B of minus 15.36. So it should be below the galactic plane, so Z minus, and that actually sort of pans out with what it says on the star map, which is an X of 72.15, a Y of minus 66.87.
Wait, hold on, go back. What was the X?
Here, I'll just bring this up. So Elite Dangerous has this map, and I'm not sure what it is on the map, but I'm going to find. So let's write these down. This is Bellatrix. So this is, of course, my home system. So we want that to be as accurate as possible, obviously.
Was that 1565?
So, well, yeah, hang on real quick. You know what I can do? I can do this.
Yeah.
Got it.
1565. Hey.
And then I just need to move it over somehow. I can't move it over. I'll move me over.
Y equals.
Can you read that?
Yep.
So this is by the Elite Dangerous map. So these XYZ coordinates may not be correct at all. But what I'll do next is find what Earth is in Elite Dangerous speak, and that should give us, because it's mentioning L and B right here, that's galactic. So this is a galactic coordinate. Because it says here's the equatorial, which is right ascension 5 hours 27 minutes 48 seconds, and declination 6 degrees 23 point. You can see why this is a mess trying to get any of these things to do anything.
Right.
Okay, so Elite Dangerous map. How do I search? Maybe. I guess not. So okay, I'm into this. How do we search it?
Bellatrix, right?
Right. I'm into this plan. Huh, so. Okay, so looks like the coordinates for Sol are 0, 0, 0.
Okay. We're the center of the universe. Don't you know that?
Yep. They've been posting memes like that too all like week. I've been seeing memes, which is we've decided here in Star Trek, we're going to, as the Federation grows, we're going to place all the star maps. By the way, we're in sector 001. Everybody else, whoa, wait, what? And all of our starships will be named the USS Bob and the USS Tim. Every other race. Wait. So,
in fairness, when I was researching this, I was thinking, like, why don't they just use the center of the galaxy? Well, it turns out the center of the galaxy isn't perfectly spherical. It's like a bar.
Yep.
So you'd have to, defining the center of that is probably going to be difficult.
Well, that's why you use Sagittarius A prime, which is registered in the system as SGRA with an asterisk, and that's the center. That's the black hole at the center of our galaxy. Okay, no problem. The problem is that you have to find the center point of the black hole, and that black hole is huge, and moving, and asymmetrical.
Right.
There's a number of stars that orbit Sagittarius A prime, and that's how we know it's there. It's because these stars are like like one of the stars is moving at 35% the speed of light. I mean, like it's moving so fast around that black hole. So you actually like literally they've been watching it from day to day move, around the black hole, and so they know where Sagittarius A prime is, but it itself is amorphous because it's a black hole and you can't see it.
Right.
So it's kind of been tough, but that's where I'm going to set all of my coordinates. It is galactocentric as well, as far as because you're right, Bellatrix Rising, they would have already sent a ship out there and hung out in the middle of the, near the galactic black hole, and they mapped it to like the 10 feet. So once we figure this out, I can just adjust the XYZ to a fit.
Right.
And really what they're probably going to do is set up everything in grids like a pizza box, like a pizza. So it's a grid where at Sagittarius A prime it's only like 2 kilometers, and the box is like the other side of the box is 3 kilometers and 2 kilometers and 3 kilometers, and you just draw a line. So it's like a slice of pizza going all the way out. So I don't know if this helps, but I mean, that's we can probably use these if I don't know whether they're doing this in light years or no, it's probably light years, because 250 is about the right distance for Bellatrix.
And was that the galactic coordinates, the XYZ?
Yeah.
Or was that...
So what we just did about Bellatrix, if we assume this is, we assume that Earth is 0, 0, 0. This one is showing galactic coordinates. That's this here, not the green ones, but these. It says, the galactic coordinates, it's saying its L and B show up as 252 at a distance of 252, which is exactly what it should be, 250 light years.
Okay, hold on. Let me also get that then.
Yeah, so let's get the L and the B on it, just so you can do the correct. Also, galactic coordinates aren't done in hours, minutes, and seconds, which is so much nicer to deal with.
That's the R. The L. 197. 342. I need the B.
Emily, did we ever talk to? I mean, I said, well, I mean, we were doing good, but now I hope we didn't scare you away. By talking about all this weird space stuff. I haven't seen you here before, so.
Now, do you want the RLB or do you want the XYZ just on the galactic?
XYZ, but you can use the RLB to check because you could do a reverse trigonometry on it. Right, and check, see if it comes back as RLB, because that is the galactically speaking. But I think that this is, I don't know what this is written in, like light years or bananas, or who knows what this coordinate system is. I assume it's light years, but it could be parsecs, and a parsec is 3.6 light years. So,
that I happen to know the HIP for Bellatrix?
Not off the top of my head, but I've got it in the list. Let's spin up my my old Excel file on this, because that's what it really likes, is loving Excel. Primary database. spinning that up? I think we lost Emily, which makes sense. We are talking about boring stuff. Not doing a lot of art today. 25336.
25336.
Mm-hmm.
Cool.
That one should read this, whatever, 72, 66, minus 66, and minus 232.
All right. Let's see what so the values of the XYZ on that page might be galactic. Because according to the database, it's 38, negative 73, negative 240.
Okay.
So run that through the system and see if my galactic conversion gets the numbers you gave.
So wait, your database is reading 72.15 minus 66 and minus 232?
It is measuring the X at 38.2, the Y at negative 73.5, and the Z at negative 240.179.
Huh.
That's the star dB. That's the Celestia value.
Yeah. No, I'm with you. What does it read for? Well, let's make sure that Celestia is saying all the right stuff.
Mm-hmm.
Right. Celestia reads. Because that's kind of.
Unless I wrote the number down wrong. That was 25336, right?
For the numbers?
For the HIP.
Oh, I'm sorry. There's so many numbers that are spinning around here.
Right.
Yeah, 25336.
Okay, cool.
The problem is that it should read. Well. So the galactic coordinates L reads in at 197.242. Okay, I'm checking something else. Hang on.
So my galactic values are nowhere near close.
Right, that's what I was saying. They're nowhere near that. It's in a different place. So, all right, Bellatrix, Gamma Orionis. IRC coordinates. Galactic coordinates are 196.927.
196.927.
Yeah. So this is Simbad. This is the galactic database.
Mm-hmm.
So this is the actual, like, what astronomy pulls. So when astronomy wants to find where Bellatrix is, they come to this website. This is really where it is. Like, all of these numbers mean something important here. So
Right.
that's why it says J2000, just so you know it's what they're talking about. It's from the J2000 position because it's moving.
Oh. Can you send me the link to that website?
Can I? Huh?
Can you link me that website?
Yeah.
That's a pretty cool website. I might be able to scrape that.
Oh, yeah? Yeah, you probably can. Although Gaia's database is a little... says that's Bellatrix data. But let me also pull up, just so that we're on this. So part of this is that this is a moving target.
Right.
Because Gaia is loading information as fast as the probe can send it, but it's sending it via high gain antenna. And so what happens is you get a chunk of data, and then you get a new chunk of data, and then you get a new chunk of data, So you can download the entire database here, but they're huge, right? And you can, because this is ESA, so like they're totally willing to just give you all the data, but it's a massive chunk.
Yeah.
You can get to the DR3, but I've noticed some weird stuff. If it's a named object, you can't find it for some reason. Like Bellatrix, I can't find, even with its HIP number, which is really weird, because I'm not sure what that means or why. But the release 3 came out almost a year ago with new data. I can send you this website too, so that you know more. Because the Gaia archive is likely more accurate than Simbad sometimes, because Simbad has to do the translations to update everything. So that's why I'm saying sometimes it's a moving target. And the error may not necessarily be in our math, but the fact that you got DR2's location of this star and Celestia's running DR3's translation of this star. You know what I mean? And it's like, really? and of course Gaia is more detailed than Hipparchos, which is the probe that went before it. Hipparchos was in the 90s, and so the resolution of the cameras on Gaia are much better.
Right.
That's what that HIP number is. That's the Hipparchos number. That's the number assigned to it when that probe went out. And when we have to deal with the ones that are Tycho, that's the ones that have the 10-digit number. That's because the Tycho database predated the Hipparchos database. And if Hipparchos didn't target the star during its lifespan, then they just leave it its original Tycho database number. And so the problem is Celestia reads the database, the Tycho database number, as a fake HIP number. So what they did was they just encode the HIP number to be the Tycho number in reverse. I'm not exactly sure why they did that, but Celestia's old. I mean, like, it was written in 2005 or 2006, and somebody else has taken the code and modified it and made it better and kept it up to date and things like that.
Right.
But it was written in 05 or 06, and it's been modified since then. So there are some things where it's like nobody knows why this, because the guy that originally wrote it gave up, walked off the internet, disappeared. You know what I mean? And just left the source code out there and said, you guys can deal with it. So some stuff, like, they don't know why he did this or he did that or whatever. I'm noticing that a lot when I'm on their Discord channel. They're like, we don't know why this code's this way. Nobody knows why this code's this way.
That's typical.
Right? And so they're like, we want to redo it, but as soon as we redo it, it's going to reread everything in there. And then all of a sudden, all of our stars will disappear,
right,
and we'll lose track of stuff.
Sounds like they need to make a standards body for star positioning and identifying and all that stuff. We do in technology all the time. Why not?
Yeah.
Scientists can do it too. Okay.
Are you using that thing called Cocoa?
No.
Oh. I just tripped over it on GitHub. It's, coordinate converter, galactic, equatorial, and Cartesian into each other.
What language is it for? Looks like it's for C.
Yeah, this is in C though.
Yeah. So. I'm not a C programmer.
We're not trying to get that far into it. We don't need that kind of. We need it to process in a billionth of a second. You know what? I really don't care if this takes all day to convert. I'm fine. I only need these numbers once. Once we're done and everything's converted, then I'm fine. But if you can take the entire database from Celestia and convert it over, then anytime I need any future stars, they'll all be still in the correct coordinate set.
Right.
Because I was thinking about saying, well, if it's easier, Bill, why don't you just take the 150 stars I need so far? But then I was like, no, because then I'll need some other star in like 2 months. And I'll be like, Bill, will you please run this through your thing? You'd be like, stop doing this. This is so annoying. Oh, Julian Day modules. Horribly useful, since it keeps asking me when to position my time. Equatorial coordinates. Let's check that. What our numbers are for this, right? Well, we know that in.
That's the thing, is like, what values are those? They're not specific. You have galactic, but galactic what? The L and B? What about the R?
Yeah, because it's missing the distance. Distance data. But it can tell me the right ascension to longitude and the declination to latitude. So, I mean, that's just doing a spherical transformation across the globe. So I can't do 3D. I can't do X, Y, and Z with that because I do need the distance.
Right.
Geodetic. What's geodetic? Doesn't matter. You can't do it. So there. Apparent coordinates module. Oh. This isn't actually interable. This is a screenshot. Gotcha. Ecliptic angular distance. Oh. Geodetic coordinates module. This is nearly true. It assumes that the Earth is a perfect sphere. This is almost true.
In the Gaia data sets, what's the difference between the GDR and the GEDR?
I'm sorry, one more time.
In the Gaia database, what's the difference between the GDR and the GEDR?
So GDR is the release, but GEDR is not. That's a partial release. So they had a half release at one point. You want the GDR.
So 1, 2, and 3 are just different segments of the same.
Yeah, so yeah, it's doing 1 billion stars at a time. So GDR1 is only the first billion stars. GDR2 is like 2 billion stars or whatever, and then GDR3 is 3 billion stars. But each release has the previous stars in it.
Okay, so I want the third release.
Right, and they're just putting it up there.
And they have a whole bunch of stuff. It looks like. I guess it's the Gaia source.
Yeah, it's not. This is why the amount of data that's on there is brutal. I mean, because it's all of it. It's all of it there. Where is it?
Just yeah. Like.
Somewhere there was search. Oh. Yeah, that's the weirdest thing. And that's the thing that I don't get. 25336. Yeah, that's so weird. It can't find Bellatrix. Which is so weird. It doesn't exist as far. I mean, it's even resolved by Sinbad. So it's like it knows which one it is. So strange. So usually what I do is I go looking for Poropar because it's right next to it. 26729.
Pepper's back. He'll be joining soon.
Right?
You have my drink?
It's upstairs.
Okay.
So I went to the doctor's office guy.
Uh-huh.
Right. Guess what they did to my head? Because I went to the chiropractors. They adjusted my scalp.
And they adjusted your scalp?
Yep.
I hate it when they pop my neck. I've watched too many movies, you know? And anybody who just comes up and goes, you know, I'm like, I'm dead.
The only thing I think in my head is just relax, just be relaxed. Because if you tighten up, you'll make it worse.
Right.
So just be relaxed. Crap. Okay. That felt good. I'm good.
Yeah, so this is what the data reads out when you're on Gaia database. So this is a star that's right next to Bellatrix because it doesn't pull up Bellatrix Good morning, can. But this is the database number for it. And then here's the right ascension and declination, and it's parallax. The parallax is the one that we can do the math on to get distance, because it doesn't give us the distance, it just gives us our parallax number. And that's an easy math thing to translate that to distance.
Right. Yeah, I started looking at this because I was like, okay, the main problem that I'm seeing is that we're trying to use Cartesian coordinates, and nothing out there is like working well with Cartesian.
Mm-hmm.
And that's what the Celestia database has everything stored as, is Cartesian coordinates.
Right.
Which makes sense because they're trying to construct a 3D model on a computer. So Cartesian is way better for what they're doing. But maybe we need to use the Gaia data set directly, convert off of that, and then convert that to Cartesian so that you can plot them.
I'm okay with that too. The Gaia database has the L and the B in it.
And I know that the Python library, AstroPy, works with all of those. So.
Yeah, I'm okay with that. The only thing is, do you want to convert the entire frickin' database?
Well, once I figure out the methods to do it, then I can just run the list through and I'm like, okay, convert the next one, and I'll just process them all. I just need to know, I need to do one right, and then I need to do them all.
Right. Works for me. That works for me.
It works for you. It works for you.
Well, then let's look at getting the Gaia database to give you a set of data that we can use to tag in. So let me start this. Hang on. Okay, so the galactic database, given its normal setup, has galactic north at 12 hours 51 minutes, 51.4 minutes. And declination. So do you want me to do those conversions for you real quick?
Sure.
I'll just grab a piece of paper here, like a normal human, and write stuff down like we're supposed to. And it makes me feel like I'm doing something, since you're doing all this nice work for me.
I just need, my input should look like this, my output should look like that.
Right? I'm good.
If I have those two things, I can write a test and I can program, and once I get the right answer, then I can rinse and repeat.
Right.
It's really hard to code when it's like, I need an output. Okay, what does the output look like? I don't know. Okay. I can just give you any number then. Great.
Right?
Put a random number generator in there. It'll be great.
Galactic center, Sagittarius A prime, and that's at 17 hours. I'll convert these in a second. I'm just writing them down while we've got it. 5.6 minutes minus 28.94 degrees. Okay. Then the anticenter would be 5 hours 45.6 minutes by positive 28.94 degrees. Galactic north then is 12 hours 4 minutes. This is why it's so maddening, though. Declination is 27.13 degrees. And then galactic south is 0 hours. 1.4 minutes. Minus 27.3 degrees. And of course, it's not giving me my y coordinates at all. We'll worry about those in a second. Because all I need to do is just run spherical trigonometry on these. And this is just going to give us a shot. It's not going to give us a distance yet. We'll work on that. I'll find one at a range that'll be at roughly appropriate in distance. Astro calculator. Meow. All right. Page not found. Like, here's NASA's thing. It's got it for you. Oh, page not found. And here's where it's explaining how to do it.
Right. Mathematicians and programmers have different mindsets. What is it? I was watching a thing. Mathematicians have seen too much enjoyment about being cursed, I think is the word.
Uh-huh.
Cursed? Let's go the correctly. Definition of cursed.
Is that J2000 or observation F?
Well, anyways, they love taking complicated things and boiling them down to a very small formula, which is probably great for mathematicians, right? It's an easy payload to carry from person to person. E equals mc squared. But when you have to convert that into programming language, computers don't have those functions.
Right.
We have basic functions. So we need the opposite of that. We need the more elaborate description that says, oh, just add these two things together, divide that, multiply by this, blah, 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 blah. Do the cosine of that. Functions, tools I can use. Not this very small thing that there's no function that does that. That's why there's literally jobs for math or for programmers that do math-specific programming, and there's a specific language for it, which probably has some of those tools.
Right.
Okay, I'm working in Python. Oops.
So it says the right longitude, so the L on this one is 179.9945, and the B don't have those numbers though. The B, which kind of makes sense, is 0.00. That makes sense because it's headed the other direction. So that makes sense that it should be 0. So then going forward is 17 hours, 45.6 minutes. And this should be minus 28.94. Go to Galactic calculate. Yep, this one goes the other direction. Okay, good. This is down to 9944.
Yeah, I had it right. Ters, T-E-R-S.
Yeah. And the B is 0.0, which makes sense. 0.00. Because its degrees should be along that one axis headed towards the galactic center. All right. And then now we'll go straight down, which is 0 hours, 5.4 minutes.
I'll be right back. I'm going to run up and grab a drink.
No problem. It's going to take a second anyway. All right. You had to step away to do work.
That's what he always says.
I know, right? He keeps stepping away to do work. Let's double check this before 0 degrees this way. And then 359. So B0 I'll bet you that's exactly what we're supposed to do. Select object SGRA prime. Wonder if it's in the right spot. Look at that. Right where it's supposed to be. Okay. So 359.994L is right here. I find it funny that it's just off 00. So it's not actually on 00. It's just off it to the left. However, double checking it in Celestia, SGR A prime, Sagittarius A prime is at, and you can see right here we're at 0 degrees and 0 degrees. So the cross of 0 and 0 galactically. And it's just off to the left of it. And the opposite of that is still 0, but at 179, of course. I actually, now that I say it, I'm feeling kind of silly because, of course, it should just be pretty straight up, right? All of our coordinates will be, 180, L180 and B0 versus L0 and B0. And then straight up would be B90 and L201? No. Why is it 201? What does that mean? Because straight up should be... What would be straight up? That's all right, Brent. I wonder if I can find the star by range. Because I think we might be going about this the wrong way. Like, what if we were to go the other direction? And instead go from galactic and do 0 and 0, and then say go to equatorial and calculate that, right? So instead of doing it this way, 0 and 0 of galactic coordinates.
Well, I'm going to be inputting whatever's in the Gaia database, which I assume is the J2000.
Uh-huh.
So I'm going to be inputting those numbers and expecting the output to be whatever the galactic is.
Okay. So let's find us a star that's at 0, 0 and at a certain distance. And then one that's at 180, 0 and a certain distance. And then one at 90 and 0 and a certain distance. You know what I mean? Like, yeah. That way you can test it because it should come out, within error rate of X, Y, or Z. Because the more I think about this, we're overcomplicating it. It doesn't have to be this hard, right? Galactic coordinates, we're looking at 0, 90, 180, and 270. With the up being 90 or the down being 90. You know what I mean? Like, that's pretty straight up. We're just looking at 4 points around the compass on galactic, plus up 90 and down 90. Everything else should be just straight up. And then all we need to do is just find, there's got to be a star that's on that line somewhere. Right. And all we'll have then is decide what its parallax should be. And then you should be able to just hit a shot on that. You know what I mean? And then if your galactic database is correct, then the stars that are at those 6 points should line up. You should see a star at all 6 points.
Right.
And then we know that the database is correct. Well, let me do that for you real quick. Because this should be 0, 0. And this should be 180, 0. Then this should be, which way is 90? Is it to the left or to the right? Is it left-hand rule or right-hand rule? Let's see. Shall we? I've already centered in because I think it's left-hand rule. Okay, so there's 0 and 0. So it's right-hand rule. So this is 90, comma 0. And this is 270, comma 0. And then up would be anything, comma, because that would be like, what is straight up for these? It's anything. So let's just pick a number and make it 90, comma 90, and 90, comma minus 90. Right? So those are our 4 stars. So all we need to do is go work. We're going way too complicated on this. Gaia archive, basic. We're actually going to take that out, go to advanced, and Gaia release 3, Gaia source. Okay. And then yeah, the early release data was different than the release data. So reset form. Gaia release 3 source. Maybe I need to be in basic and I just don't know what I'm talking about here. Extra conditioning, extra display columns. We don't need that. Well, we probably do. Parallax, PMRA. I don't need that. I don't need that. Or that. Or that. I like that though. One of these guys.
Shake it on.
Yesterday with all the birthday festivities.
Yep, merry birthday.
The Bride of Frankenstein.
There you go. I like it.
You giving her the tall hair with the white streaks?
Excuse me, I need to go show it to him in person. Don't speak though.
Oh, I see it now. Oh, it didn't show up on the camera that well. Sorry.
It doesn't.
You need to get your camera over your desk.
No, I just need to get better lighting than my desk.
Mm-hmm. I say we get a camera over the desk.
I already have a camera over our desk. I just need to get that one.
If you think, in the chat, if you think he should have a camera over that desk additionally, put a 1. Just hit 1 and enter. This is called audience engagement, right?
Right? Okay, let's see if this tries. No results found. Okay, so the problem with this is such a computer thing. It's like, is it not finding it because I didn't put in a name and it needs a name, or is it not finding it because there's no stars in the zone? Right.
Right, there's 1. So I need a camera over that desk. 1 vote, it's decided.
Right.
It's National Paranormal Day. Okay?
Mm-hmm.
Draw your favorite Boo brother.
I wonder if I can search for it in here. No, not that way. It's just so frustrating because like all of these are almost exactly what I need, but not quite. You know.
What was that page you were using to convert the values from one to another?
Hang on real quick. Yeah, here's our problem with the black hole in the center of the universe. The page that I was using to convert from one to another. Let's see if we can find that. I think I've closed it. I have closed it already. I just did a Google search on convert from one to another. So. Uh-oh. Wow, I just did something. Trying to find a more accurate star. We'll find one here in just a second. How many of these do you want to? I mean, I guess we really only need a couple, right? We don't need all 6 of them.
Yeah, just a handful.
For our check.
Technically 3.
Yeah, I'll do 3. I'll do x equals 0. And then I'll do to the right and straight up. Man, how far in was I zoomed in? Must have been zoomed in a lot. Okay, 0 and 0. There we go. Yeah, there's nobody at 0 degrees 0. This is so weird. It shouldn't be this hard. It really is. It shouldn't be this hard. Really?
Really?
I mean, I guess I feel stupid saying that I can find it using Google Sky, but apparently I can find it using Google Sky. Except that how do you hit the search bar on it? All right, I'll play. How do I get to the search bar? They're like, oh, in Google Sky, you just click it in the search bar. Yeah, I don't see a search bar. Do you guys see a search bar?
So apparently Gaia tells you exactly how to do the transformation. In mathematics speak, of course. Google.
Mm-hmm.
I have to know if ChatGPT can deal with this or not. How good are you really? Let's see. That 255.
I find it so weird that nobody has ever done this. You know what I mean? Like there isn't a website. Somebody was like, I've got to convert all this to XYZ. So here's what we did. We went on ahead and just did this. And it's so weird that I'm like, nobody has ever decided to make a map or anything. You know what I mean?
I'm pretty sure ChatGPT doesn't get math speak.
Right?
It's thinking hard right now. Like, well, what is that?
Andromeda is so big you can actually see it if you could see it.
Mm-hmm.
Like it's a big thing. It's twice or three times the size of the moon in the night sky. But it's so dim you can't see it. We just need one spot. It's like you can find it here, but there's no search bar. All you need to do is type it in the search bar, but there's no search bar. And so it's so frustrating because it's like, how do you search in Google Sky? I Googled. It says, easy, type the thing in the search bar. I'm like, there's no search bar. How do you search? I mean, like, that's what I was saying. I was like, search. How do I search on Google Sky? 1, search the sky. To search for a celestial object, enter a search term and click search. There's no search term.
Weird.
Like, there's no search. How do I search on Google Sky? This is so frustrating. Everything is like this. Oh, the answer is really simple. You do this one thing. Oh, they disabled that feature about 2 years ago or whatever. You know,
never updated the documentation.
I mean, am I missing something? Can you guys see a search? Maybe I should put it in English US, but still. Can you guys see a search term location here anywhere?
No. Maybe if you just search Google Sky and then the name of the thing you're looking for.
The problem is we're looking for a star at, oh, well, maybe, you know what? Let's look for a real star then. And see what it comes up with. Must include Bellatrix. Can't do that. That's not a thing. This is so hard. What star is at galactic lon 0 lat 0? At least you know what we're talking about now. What are the galactic XYZ coordinates? It just tells me what it is. And in Star Wars mode, which means we don't want to trust that. I mean, nothing wrong with Star Wars, but I'm not sure that's necessarily a accurate convention. Maybe search by galactic coordinates. That's No Man's Sky. Coordinate query. You will accept the following: 0.0 space 0.0. About 4 objects. Okay. There we go. That's what we were looking for. None of them are ones that we would be able to find necessarily, would we? But at least we found the right thing here. That's a gamma ray burst. We're not going to find anything on that. That's a quasar.
Maybe what we need are pulsars.
Right? Also, that's...
Isn't that what they use to map everything now?
Right? Pulsars. It's because pulsars are really, really easy to... They're putting out so much energy. They don't bleed a lot of stuff away.
Mm-hmm.
So that's a supernova.
That's a weird one. I'm just having fun overwhelming ChatGPT with something it cannot understand.
All right, here we go. We've got something that's closer now. So 0, 0, because these Tychos are actual stars. This is the first closest actual star. Galactically, it's at 0.02 and 0.01. It's far closer than we think it. There, that's pretty accurate there, I think. So let's see what we've got on here. So here's the Gaia DR3 release number on it, which is huge. Let me just copy it to
you. So what astrological item is this?
It's a star.
Or just a star? Okay.
Yeah, but I should be able to give you. You should be able to find this at 0000. That's straight to the galactic center. So, Ward Galactic Center. There. That way you can. And now that I've figured out what to do this with, we can do.
And that was from Sinbad? Or Sinbad? Yeah.
Yeah. Zero comma 00. Okay. We'll go for a radius of 5 arc minutes so that we can see something. Well, all that's out the other direction is a bunch of non-star issues here. How far off are we going to be before we hit a star? Oh, that's actually a real star. Here is the other side. Galactic anti-center. Coordinate query 90.00.
So the galactic center, that's as if you were from Earth looking straight at the center of the Milky Way.
Yeah, that's the center of the Milky Way.
And the anti one is on the exact opposite side.
Yeah, it should be 180 degrees out. Oh, it's got a Gaia hit straight on at that distance. It's not far off. It's a white dwarf candidate, but it's in the DR3 release. So this one is then 90 degrees to the left, or to the right. So 90.0, 0. So there's no right ascension to that. Right? And then, I wish I'd done this before. I'm like, this is so simple. 90.0 space 90.0. Give it a 5 arc-minute radius. And all I've got is a region defined in the sky. So you have to go a little bit broader than that. That gives us some. 5, there's nothing. I see a whole bunch of dots in there. Submit query. Are we having a problem with this? Maybe I clicked the wrong button. Do we just have nothing in there on the Sinbad? I mean, like, that's something, isn't it?
Well, no one really likes Sinbad, just like they don't like Pluto.
Right?
So, small tangent. You said Sinbad, and I did the same thing. Then I looked at it, it's Simbad.
Mm-hmm. It's Sinbad.
So, my ADD mind traveling here. So, in preparing, we're going to do a meetup for a D&D game locally here.
Uh-huh.
I assume it's just going to be a quick run, and so we're just trying to prepare on, like, you know, how do you D&D? Like, we're trying to learn everything we can. Like, we called you earlier, and we were having you help us make a character. And so we've been watching Critical Role on YouTube.
Okay.
You know who they are?
Yes.
And we're watching them.
That's Mercer. But see, Mercer is such a good DM. He's so good at it. He likes to do voices and everything like that.
Yeah. And so we're watching him, and they're joking because one of the characters, we're watching the third campaign. And he's like, the character's name is Dennis. They thought it was Dennis.
Dennis. D-A-N.
Yeah. And so, but they thought they heard Dennis. And they were like, yes, the villain's name is Dennis. All shall bow before Dennis.
Yes.
And I'm starting to learn through watching it, like, you want to have these awesome moments where, like, you roll 20s and you do these amazing things, but it's also fun and comical to just fail and fall flat on your face with all your rolls, and that the story can evolve comically from there.
Yes. Yeah, that's the thing that a lot of people have a hard time learning is failing is actually a lot of fun. And so that actually is one of the things that people have a hard time getting right off the bat, because they feel like when they fail, they've let down their partners, they've let down whatever you want to say, however you want to call it. It's always like, oh man, I didn't mean to let you down. I'm such a terrible. It's so terrible and stuff. Truth is, failing is a riot. Okay. Something's telling me we're not doing this right.
There's a lot of stars there.
Right? Legitimately, that's our biggest problem right here. Is this problem right here? Dang it.
Aha.
Okay, now I'm worried that it's not giving me the right data. Because I just typed into here on the coordinates this guy who should be straight up, but isn't. He's towards the center of the galaxy, so I'm going to now do an identifier query and try one that I know is straight down. This is why this is so hard and difficult for me. It's like I do what the numbers tell me to do. Like, oh, the numbers say that 0 and 0 should be a thing. Galactic coordinates. Oh no. Okay, so the galactic coordinates are saying roughly straight down, right? But it's L and B read this way. I see this. This is the thing that's interesting, is that the L and B are reading this way, which is 009.757, and then minus 89 point. So that's minus 90. Let's see what we got here. Let's go for 0.
Yeah, the page doesn't really like describe like what are the values outside of the brackets and what are the values inside the brackets.
Right? Because like, why do we have 3 numbers here?
Mm-hmm.
This looks almost like this is error ellipse, right? But it's
Error ellipse, error ellipse, error ellipse.
So that's not, well, here, let's try coordinate query, and let's try 0.00 space minus 90.0 and give 5 arc minute search. Nothing there. So let's try 10 arc minute. Okay. And that puts you right in the way of it, though.
To make it easier, they don't need to be precisely anywhere. I just need to know the value input and the value output. It doesn't matter where they are. I mean, it's nice to have one that's generally above, generally below, generally in front, generally behind, generally to the left, generally to the right, just to make sure 3-dimensionally I've gotten it right.
Right.
But it doesn't need to be precisely anything.
So we could pick one just generally to the left galactically and generally to the right. You're right. It doesn't have to be that specific.
Mm-hmm.
Because these are set to galactic coordinates. Let's find the biggest star that we know, because they're going to be straight down. The biggest star we've got is what? Let's take a. All right. Then straight down, give or take, is HIP 4, 5, 7 below us.
4,
So
5, 7.
And that should come up at Z minus about 709 light years. So give or take, right? That's directly below.
Below.
Yeah, it's directly down. And now I'll go to directly up, and I'll pick one that's directly above, give or take. Okay, so directly above us then is HIP 62763, and that should be at Z plus 274 light years.
There you go. Dracula.
Nice. This is much easier. I'm trying to be way accurate, and it's like, well, we don't have to be exactly accurate. You're right. It just needs to be roughly in the right direction. Right? So then heading into the city, into the galaxy is HIP 8707. I'll show you this in a second. And that should be X minus 1154 light years. Right? So that should be, and 0Z-ish, give or take. And then going the other direction.
What was the HIP on that?
That one's HIP 87072.
Okay. And that one was to the left?
No, that's towards the center, so that should be x minus 1154 light years.
That's galactic center.
Yeah, galactic coordinates. And at 180, 0, going the other direction would be HIP 27172, which should be at x plus. Whoa. It's in kiloparsecs. Let me find something a little closer. Maybe not that far away. So let's not take that one. Yeah, there we go. We'll do that one instead. So scratch that one. 27830, which should be at x plus 397.4 light years.
And this is behind?
Yeah, so 180, 0. So x plus 347 at that point at 0, z, and y should be 0 as well, give or take, roughly. And then I'll come up on 270, which should put us here-ish. I'll pick you. Yeah, there we go. At 270, 0, we will have HIP 44511, and this should be y equals 300 light years. So that's at 270 degrees.
Is that the left or the right?
To the left, I guess. Oh, wait. Let's think about this. So if x0 is aimed straight at the galactic center, then 90 degrees is to the right, 180 degrees is behind us, and 270 degrees is to the left. Which way is x minus? Is that to the left?
I'm not sure.
I mean, y minus. Which way would be minus y on the Cartesian? Maybe to the left, yeah?
I think so.
Yeah, so we'll say minus y minus 300 light years. And then we'll go the other direction to 90 degrees and give you something that's roughly at 90 degrees. Give or take. And at the 90 degree, we have HIP 104194, and that one's at y plus 1311 light years. Okay, so if we want to do a conversion on this, I don't know if you wrote all these down.
I did not. I wrote the HIPs though.
Yeah, so HIP 62763 should be roughly at x equals 0, y equals 0, and z equals plus 274. Okay. Then we go to HIP 87072, and that should be at x equals minus 1154, y equals 0, and z equals 0. Okay.
These are like, this is what it'll convert to. This is the galactic number?
Yeah, this is the last step. They should be roughly this.
Okay.
Because they're not exactly at these points, but they're the closest stars. So they should be in an error rate of about 1 degree or 2 degrees.
Okay.
Then HIP 4577 should be at X equals 0, Y equals 0, and Z equals minus 709. Okay. Then HIP 104194 should be at X equals 0, comma, Y equals 1311, and then Z equals 0.
Okay.
Then we have HIP 27830, and that's X equals 397, Y equals 0, and Z equals 0. And the last one that we have then is HIP 44511, which should be X equals 0, Y equals minus 300, Z equals 0. And that should give you a star at each one of the 6 points around you that should equal roughly that.
That was Y equals minus 300?
Yes, minus 300. There we go. We just overthought it.
Mm-hmm.
I just look to all 6 points from Celestia and then just do the distance and just change the X or the Y or the Z numbers. It really wasn't that hard. I overthought it. That's not uncommon for me. And of course, Earth will be at 0, 0, 0. So that's your center point.
Alrighty.
But I'm not sure that any of these releases will talk about Earth at all. So, you know.
I just want to see what I have now. If we're ever close at all.
The Dune trailer comes out today.
Brent already posted it on Facebook.
That's what I mean. It's like, that's what I was reading. Was the Dune trailer.
Is it like Dune from the movie that was recently released? That was meant to be a two-parter? I haven't even seen the movie yet.
Yeah, the second part, if you will, of the two-parter.
I never knew it was going to be a two-parter.
That's because it's a big enough.
Yeah.
Or it's a big enough book, I guess.
I need to, now that I have the nice new TV, I need to like watch it on there. My 477 should. All right, my conversions definitely were not working that I had originally, so so noted. Well, what was that? Can you link me that website you were using to do the conversion?
The one website I was doing what?
That did the conversions.
There was something, I don't remember where I came up with it though.
Oh, okay.
I just typed in convert equatorial to.
Well, it's a J2000 value, isn't it?
Yes.
That's what Celestia has.
Yes.
2000 to And also this that query. HTTP. One. Okay.
So it's 11:05.
It is. I'm looking for one last bit of information so I can make sure if you're capturing from the Gaia data, I want to make sure you capture a certain field.
I wanted to know if you had some time after the show to talk.
If I had a what?
Time after the show to talk. I need to go over something with you.
Oh, yeah. I can do that for you. You don't mind me eating.
No, I don't. I would prefer you to eat. It means that you won't die of starvation.
It is weird whenever I die of starvation. Just saying. It's a word I'm having a hard time finding.
You know if all those units were KPC or were they another kind of unit?
Nope, they should be light years. KPC is kiloparsecs, so that's 1,000, or that's 3,600. So times 3,000, or divided by, times 3,600. Because 3.6 parsecs in a light year, or 3.6 light years in a parsec, sorry. And then that's in thousands of parsecs. So that's how you'll get to that number. None of them should be over a kiloparsec. I found one of them at kiloparsecs and said, let's back that off. So we only have things that are within, about 400 light years. Well, with the exception of the one that's headed straight towards the galactic center, that's at 1,100 light years. and then the one to the right, but that's all still within 1 kiloparsec. So all the stars are within 1 kiloparsec.
That. It says you. Now. When we run. You need representation partition.
Oh, wait a minute. Whoa.
Oh. No absence. If you do.
There are reference frames that we can use. Who knew? I don't know why this is so hard. I need to know the angle of the star, like which angle is it at? Because like we are rotated, our solar system's rotated 60 degrees. I need to know, say, what Bellatrix is rotated, because we're not all 60 degrees off angle. So I'm trying to figure that out. I don't know what number in all of these numbers in the Gaia data is it finding, you know? That's it.
Yes.
How much longer are you guys going to be on stream?
I don't know. I mean, we could probably end the stream and just stay live because you wanted to talk to me about something offline.
Yeah.
That's probably what we should do. I think we've lost pretty much everybody.
Okay.
So, let's go on ahead and do that. We'll close the stream down and we'll just stay on. Okay.
Alrighty.
Thank you, everybody, for joining us, even though we've been kind of just number crunching the whole time, but it's still cool. And we'll see you all tonight. Keep your eyes on the stars. Bye-bye.